So, may invest in an annuity that earns interest rate of 5.2% per annum, compounding monthly. So we've got the PPY there. And it says monthly payments are received from this annuity. So because they're getting, when they invest the money, the PV will be negative, but when their payments, because they're receiving a payment, that'll be a positive payment. Okay, so the balance of the annuity after 5 years was that. So they've given me a total. And then they said the balance of the annuity after 10 years is that. So then it's asking for the monthly payment is the question. So if I went through my finance solver and I wrote out all the titles and I'm trying to find out what I want to know. So because this is the question, so I'll put a question mark on that. So it means I should be able to fill in everything else. So if you have a look, I know that the interest rate is 5.2. I can see PPY is 12. And if I look at it, I don't have, they haven't actually told me how long this annuity lasts, and it hasn't given me a PV or an FV. So what I'm going to do, it has given me a time period though. So here, if you look in this part here, from 5 years to 10 years, that's a 5-year period. So what I'm going to do is pretend that's the period that I have. And what I'm going to say is at 5 years, at the beginning, I'm going to call that my PV, and I'll call this my FV at the end. So in that case, I'm going to pretend she invests that 137.84.93, and because it's 5 years, it'll be 5 times 12, and after 5 years, she still has in her investment 6692.27. So now I've filled all that in, I can go to this, and I'll end up with 1500. So I'll press the enter, and I get that answer. Okay, so with this one, 4 lines of the amortization table for an annuity investment are shown below, and the interest rate for this investment remains constant, but payments may vary. So they say that, so you have to be careful with that. That was important information, because they say payments may vary. So you can see, even though this was 100, 100, and 100, the next one could be different, and that they're prompting you for that. So the balance of this investment after payment 20 was 7,500. The value of payment number 20 is closest to. So what you have to do is, this is an amortizing. This is an annuity investment where they're adding extra. So you can see the payment plus the interest was giving the additional addition, was showing you how much the investment was going up by. So if you look at here, this principal addition, I'll get it in a different color. Really, this is how much the investment's going up by. So really, I could do, to find this out, I'm going to use, it went to 5,000, but before it was 7233.83. So if I minus that, I get 266.17. So I know that this investment, first of all, I know it went up by that much. So we know that the payment plus the interest is going to give that. So because the interest rate hasn't changed, I'm going to have to find out how much interest we gained here. So I'll put it in green. Okay, so we need to know, we haven't been given the interest rate. So we really want how much the interest rate is, but we can work that out using one of the other statements. So we can use this interest amount and a balance before to find the interest rate. So I'll show you what I mean. So interest amount is found by going the R over the PPY over 100 and times the balance before. So really what you're doing is when you're calculating the interest for every section, you're timesing the balance before by whatever this number ends up being. So instead of like finding out all the individual parts, like the rate per annum and all that, and the PPY, which I don't know, what I'm going to do is I'm going to just pretend that whole little section is X. And that's going to tell me what I need to times it by. So what I'm saying is let X equal the R over the PPY over 100. So I'm going to use my scenario here. So where I know the 27.91 equals, and I'm just going to say X and times the balance before, which was 6977.50. All right, then I can just chuck in solve, comma X, and I end up with X being 0.004. So what happens when we took the per annum rate, we divided it by the PPY and 100, we end up with 0.004. So I can now work out that interest amount for payment 20. So for payment number 20, the interest amount is going to equal that this 0.004 times the balance before, which was 723.83, and we end up with an interest amount of 28.94. So now I know that this is 28.94. So whatever this one was, I don't know, call it Z. So the payment. So the payment plus the interest has to equal 266.17. So I'm saying the payment plus that interest has to equal 266. So you can chuck it in solve, or it pretty much the payment minus that interest will give you how much that principal addition minus the interest will tell you how much the payment was, and the payment ends up being 237. So it is a lot different to 100. In this case, something happened and they prompted you up here for it, and it was one of the last questions, so it is quite difficult. And the most common error was kids just rushing and they just picked 100. But it's not going to be that simple when it's the last question of the exam. Okay, on January 2020, Dion invested $10,500 into an investment account paying compound interest. Now, this one, so he's investing, so I can say negative PV. Now, it says compound interest. What we have to be careful, it says 0.52 quarterly. So that's actually given you, this is the quarterly rate. So if I wanted to know the quarterly rate is actually the R divided by the PPY. So if I was trying to find the actual per annum rate, I'm going to do that quarterly times 4. So that equals 2.08. And I have to be careful because that's my I on Finance Solver in case I need it. So it says at the end of each quarter after interest was credited, Dion added an additional amount of money. So if he added, that means the payments would be a negative. Okay, and it's the additional amount per quarter is modeled by this recurrence relation. So they said that they're gonna he adds every time he adds a new amount in plus the interest. So it says the balance of Dion's investment account on January the 1st, 2022. So we've got a bit of a time period here. He started on 2020 and then January 22, and remember it's quarterly. So if I get to January 22, it's been 2 years. So it's actually the quarters equal, there's been 8 quarters. So that's N equals 8. So they want the value of C. So C is the payment. They said they're going to add a payment every time, and they want to know what the payment is. So here you can use Finance Solver. So we're going to pop in our titles. Okay, so we know payment's the question. Now let's write in what we know. We know it's 8 quarters. We now know it's actually 2.08 because remember the per annum rate has to go in there. And we know he invested 10,500, and we know after 8 quarters he had that final value here. So that's a positive. And we know PPY is 4. So once we do that, we get the quarter and we get negative 215.55, and that's because he's adding an additional. So this B will be our answer. Okay, 20 years ago, Hector invested a sum of money into an account earning interest rate of 3.2%. So just invested, just like to prompt myself with negative PV, and compounded monthly. So PPY equals 12. After 10 years, he made a one-off payment of 10,000 into the account. So he's just doing it a one-off. So then after he does that, something else happens. And then they go for the next 10 years, he earned. So this now, after 10 years, for the next 10 years, we're getting a new scenario. So we've got an interest rate here, still compounding monthly. And after that 10 years, his account balance was this. So this is going to be a sort of a final value that I can use. All right, so the sum of money that Hector originally invested. So when you have these change of scenarios, sometimes good to just sort of plan out what's happened. So at first I'm going to say the first 10 years. So in his first 10 years, so this is, I'm going to talk about what I was talking about in the blue. So he had this scenario. So I'm going to say, all right, for the first 10 years, he had something happening. FV, I'm going to write these all out. Okay. So we know for the first 10 years, he was doing monthly. We know the interest rate was 3.2. We don't know the PV. He's making no other payments. He just does this one extra. So we might say 0. And we don't know, they didn't tell us anything about what his value is at the end of that first 10 years. So, but then what happens, we have the next 10 years. But just before the next 10 years, and if I I'm going to write out the solver here. And right before we start this next 10-year scenario, what happens is he added an extra one-off payment. So he would have got to this value here, whatever that was. He then added 10,000 to that, and then that becomes his new PV, yeah? And then he's off and running. So if we look at what we've got with the next 10 years, we've got 2.8, and he still would go another 10 years, so 10 times 12, and they still said it was PPY. Now, they did tell me his final value there. It was 686,904.09. So if I do that, I actually can find out what it was just before he starts the second half of this scenario. So when I do that, I end up with negative 519,320.30. But what happens is, so that was after the 10,000 was put in. So if I was going back the other way, what would I do? I would minus it, wouldn't I? Going to minus 10,000. So if I minus 10,000, then this final value would have been 509,320.30. Now I've got that, I can finally go backwards again, retype my finance solver, and I can work out what he originally invested, which ends up being, if you do it, it's 369,999.99 and so on. So it ends up being 370,000. So this is obviously continuing on, but from another question, because it's from the 2020 exam, but because we don't like consequential marks, so you can generally pick up a question even if you haven't got the bit before. So make sure you know that, because if you couldn't get the one before, keep going, you might be able to get the next bit. So it says, later Samuel took out a new reducing balance loan. He had an interest rate of 4.1% per annum, that was I, compounding monthly, PPY equals 12. And the balance of the loan after 4 years of monthly repayments was that, and the balance after the loan after 7 years was this. And Samuel will continue to make the same monthly payment. Now, to ensure the loan is fully repaid to the nearest cent, the required final payment will be in the first 7 years, he made 84 repayments. So they're just showing you, if you do, because it's 7 years, 7 times 12 is 84. So that's pretty much all they're saying. But this was like the question before, when we don't really have a start, a PV or an FE, and we're getting asked to find out how many payments there are. So when you have that, obviously N is the question, I must be able to get something else. So what I'm going to do is I'm going to pretend that the 3-year mark is the start and the 7-year mark is the finish, okay? And I know there's 3 years in between that, So if I was doing it on Finance Solver, N would be 3 times 12, because this is monthly. So the first we've got to, if we wrote down, we're trying to find what N is, but it says how many, from this point, how many more monthly payments will he have to make? So he's at the 7-year mark, he still owes that much, and we want to know how long it's going to go for. So we've got a few things missing. We can't go straight to that answer. So what we're going to, and I'll show you what we're missing. We don't know how long it's going to go for, but we also don't know the payments. So we're going to have to find out what the payments are first, and then we'll go on. So using my first scenario, this up here, I'm going to go 3 times 12. The interest rate was 4.1. I'm going to pretend he borrowed this 329,587.25. The payment's what I want to know. And after 3 years of that payment, it got to this amount. And PPY was 12. So if I do that, I find out that the payments were 2,400. Now, because it says how many more monthly repayments, this is from the 7-year mark. So I'm going to pretend from 7 years already, I'm going to pretend like we're starting again with a loan of that 7th year value. And I'm going to find out how long it's going to take, and that would be N. So I know N's going to be the question. So let's go and find that stuff out. Okay, so we know the interest rate is still the same, so 4.1. We're going to say, because we're saying it's the 7-year mark, we're going to pretend he borrows that 280,875.15. then we know he's making the 2,400. Now, if we want to know how long to fully repay the loan, that means FV equals 0. You've paid it off, and PPY is still 12. So when we do that, we find out how many more it will take, and it does say the final repayment will be a bit lower. So let's find out what that is. Okay, so when I do that, I got 149.7. So that would really be, if I go to 150, the last one is going to be less because it's not quite 150. So that helps that. And they did say the final repayment will be lower. So how many more monthly repayments? There will be 150. 150 more monthly repayments. Okay, to purchase an additional workplace equipment, Pina took out a reducing balance loan of 580,000. So that's my PV, with interest calculated monthly, so PPY equals 12. And it's got a recursive relationship shown there. And it says, showing recursive calculations determine the balance of the loan after 2 months. If you're doing it recursively, you must show it like this. So it'll be 1.002 times the balance before. So at the start it's 580,000. Then you've got to minus the payment. Oops, sorry. And you have to show all that. And if you don't show that, you're not getting that 1 mark. So we've got to do that. And then we've got to do it again. We say 1.002 times that balance before, minus the payment, and then we get that, what the value is at that time. And that will be how you've shown it. Okay, so the next one says determine the annual compound interest rate. So if you remember, this bit up here is that R value, and that R value, the big R, can be found using the annual interest rate and dividing it like that by the PPY and over 100. Now you know that that's equal to 1.002 because you can see it up there. So we could just use solve in our calculator, and we could just do solve 1.002 equals 1 plus, the R is what we're trying to find. We do know PPY was 12 and 100 and comma R, and we end up with an interest rate of 2.4% per annum. Okay, that's the annual interest rate. And then it says the final payment that is required to fully pay off this loan is smaller than any other payments by an amount less than $1. Determine this amount in dollars rounded to the nearest cents. So you just have to find, you know, when we do the final payment, we always go to the end and that FV is a little bit off. So we just have to say what it's off by. But if we go and, if I write out all the titles here, what we know is, it says how long will it take. Now we haven't been told how long this loan's going to go for. So that's the first thing I'm going to have to do. I'm going to have to find out how long it takes to pay this loan off. So if I do that, the interest rate we just worked out was 2.4. PV, we know he invested because that's the LO. This was a loan. So that's a positive. We know that payments, we can see from the recurrence relation, he's making negative 345.26. Because I want to know when the loan's paid off, that will be 0. And PPY was, we did know that was 12. So I find out that this ends up going for 239.99. So you can see it'd be 240, and the 40th is going to be, 240th is going to be that lesser amount. So I'm going to, because it's a final, I'm going to do that. I'm going to put 240 in there, and I'm going to see how much he would, the bank, how much like the bank owes him, because it's going to be a little bit less the last payment. So if I do that, and this is what we're finding out, and PPY equals 12. So when we do that, we get this one to be, it shows 0.15. So that means the bank owes you. So determine the small amount that is not required, like that you have to take it off to the nearest cent. So it's 15 cents. So 0.15 was the answer. So it says it's less than $1 by what amount less? So it's 15 cents. Okay, the original recurrence relation models the loan being fully repaid in a certain number of years using a different multiplication factor. So this bit, they're going to use, other than that, they're going to change that bit. So this bit, they're going to say using a different thing. So this bit is going to change. Okay? The loan would be fully repaid 1 year sooner. So we saw the original loan, so the original we saw was N equals 240. Was that true? I think that was going back. So if it's 1 year earlier, that means it's you're going to minus 12 monthly payments. Does that make sense? And N would be 228, because it would be 1 year sooner. So this is going to be fully paid 1 year sooner. N must be 28. So it says determine the multiplication factor. So this multiplication factor, we know, is the 1 plus the rate over the PPY over 100. Now, because it's going to change, so essentially what's going to change, R must change. The per annum rate is changing, because that's the part that's is changing. All right, so we need to find out what the new interest rate is. So I'm just going to use Finance Solver. So I'm going to go N is 228. Interest rate is what I want to know. PV was 580. He still loaned the same amount. He still made the same payments. So negative 345.26. The FV would still be 0, because we said it's going to zero off. And PPY would be 12. So if you look, we end up, the interest rate ends up being 1.9466. It says to round to 4 decimal places your final answer. So that's why I've chosen to take 4 decimal places in my interest. And now I'm going to do my new formula. So it's 1 plus 1.9466 divided by 12 over 100. And I'm going to do the 4 decimal places, and you end up getting 0.0016. So this is the final answer. That's the answer they want. They want the new one. That's what you would be multiplying it by. Okay, so with this question, let's have a look. I can't say these names. You want to invest $80,000 in a perpetuity that will provide $4,000 per year. So remember, we're going, a perpetuity is an investment, so that will be a negative PV, and it will never change. So that will also equal the positive FV on Finance Solver, and it will provide a $4,000 a year scholarship. So if you were doing that on Finance Solver, that would be a positive payment coming out to you, and that's what the yearly interest is. And then they take that $4,000 out, and then they go again with their same $80,000 for a year. So it says which of the graphs shows the value of the perpetuity over a period of 5 years. So with the perpetuity, the value doesn't change. It's always going to be 80,000. So which one is that graph? It's pretty easy to find. It's just that one that goes straight across, which is B. Okay? So, which of the following recurrence relations could model a perpetuity investment? So what you have to remember is, with a perpetuity investment, that D value, so when we have a recurrence relation, so it'll have a VO, then it has a VN plus 1. With a perpetuity, obviously you'll have this, you have the R value times the VN, and then you would be taking out a payment, okay? So if you think about this, the R value is found by going 1 plus the rate over PPY over 100. Sorry, my pen's not working. Over 100. And when you have a perpetuity, this D value is actually the R over the... Sorry, I'm going to run out of room. So it's the R over the PPY over 100 times VO. Okay? So what we're going to see is if this is a perpetuity, if you multiply the interest amount that's getting charged, if it equals the payment, then that must be a perpetuity. So what do I mean by that? This part here, I'm just going to highlight it. When you see this little part here, just the bit after 1, that part is, if you were calculating that, it's this part of that formula. It's the R over the PPY over 100. So if you take that part, which you can see is there, and if you times it by the VO, you should get the payment. So what I'm going to do, so I check out the first one. What I'm going to do is I do the 0.0029 times the VO, the 120,000, and I end up with 348. Now that doesn't match the payment here, does it? It's not the same. So then, because that's not the same, this one's not a perpetuity. So if I do the next one, where I just work out that 0.0047, so that's the interest amount. So if I do that one times 180,000, I end up with 846. So that one does match the payment on that one. So I'm going to say that is the answer to a perpetuity. So that's a quicker way to do it, is just to use the little interest part. You don't use the 1, you just do the number after the decimal point. So I'll pause it and let you do that other one. Alright, so let's have a look at this one, very similar to the one we just did. So which one of the following recurrence relations could be used to model the value of the perpetuity? So, as I said, this little part in the formula, that number, part of the number, is found with the R over the PPY over 100. So that's that part of the formula of that, the big R. Now, we know in a perpetuity, we want the payment to equal the interest. So really, this is the extra interest getting added, the extra interest amount. Okay, so, and then in a perpetuity, when we find the payment, we use, it matches the interest that's earned, so we use that times the VO. So, we're going to go, and this is the D up along here. So we're going to see which one matches. So if I do over here, I do the 0.047 and I times it by VO, which is 48,000, I end up with 2256. So that is not the same. So this one's not a perpetuity. If I do the next one, 076 times 52,000, I get 3952. So that's not the same. If I do the next one, 046 times 56,000, I get 2576. And if I do this one, 076 times 57, this one ends up being 4332. So those two match. So then therefore this one, the interest earning is getting taken out as a payment, and so it must be a perpetuity. Okay, Julie has retired from work and received a superannuation payout of $492,800. She has two options. So option one, she could invest this money in a perpetuity, so that's a negative PV, and she would receive, so that'd be a positive payment each fortnight, so that'd be PPY equals 26 for the rest of her life. So at what is the annual interest rate so earned by this perpetuity? So your I is going to be the question, and if you think about it, because we have a perpetuity, we know that negative PV is equal to positive FV. So we'll have the same number, but it'll be like that. So if I go and fill in all the things we know, now remember with a perpetuity, it doesn't matter, you just put a 1 in the time period, because every period we're back at the start. So the I is the question, and PV is negative 492,800. The payment, they receive that, so that's a positive 887.04. FV, remember, is the same, so but positive, same as PV. And PPY, it was fortnightly, so there's 26. So when we do that, we get, it said, what is the annual interest rate? And you get 4.68% per annum. There you go. Oops. All right, so that's that one. That was that option. Now, Julie could invest this money in an annuity instead of a perpetuity. So the annuity earns an interest rate of 4.32 and compounding monthly. So we probably want to pop in a few things. That's I, PPY is 12. She's going to invest, that's still negative PV. And the balance of the annuity at the end of the first year of the investment, so if it was the end of first year, N would be 1 times 12, and that would be the FV at that time. And then it says, what's the monthly payment? So if we went through, we have everything we wanted. They told me what I was in this case, 4.32. PV, she's still gonna invest that same amount. The payment is the question. FV, they told me after 1 year, and it'll be positive because it's an investment, so it's her money coming back out. And PPY is 12. Okay, and so we do that, and we get the payment to be 2,800. Okay, Alex sold his mechanics business for $360,000 and invests this amount in a perpetuity. The perpetuity earns interest rate of 5.2. So he's going to invest, that's negative PV. Because it's a perpetuity, we know negative PV is the same as positive FV. He earns interest rate, so there's my I, per annum, and it's going to be paid monthly, so PPY is 12. And then it's just asking what's the payment. So this is a pretty basic question. So we got N equals, because it's a perpetuity, we can just chuck in 1. I equals 5.2, PV equals negative 36000. Payment, so is the question, and FV is the same as PV but positive. So all these little prompts are on our summary sheet, so if you're sort of forgetting, it should look over there. And when we do that, monthly payment, it hasn't said any dollar or anything, so I'll just do 2 decimal places like that. So we get 1,560. this is continuing on from the last bit, the last question. It says, later Alex converts the perpetuity into an annuity investment. So, with this now, it's still going to be negative PV. Now, because you're continuing on from the question before, we know the perpetuity's total value didn't change because you only use the interest. So you actually know that the PV in this case was what he originally invested in that perpetuity. So we're going to say the PV is going to be negative 360,000. So we know that. So you might have to realize that because this is part B. And it says he invested in an annuity earning 3.8% per annum. So they just gave me the I there, compounding monthly. So PPY equals 12. And for the first 4 years, Alex makes a further payment each month of $500 to his investment. So he's adding that in. So that's a negative payment. Yeah, so it'll be a negative 500 because he's gonna try to make this investment grow. Okay, and after 4 years of these regular payments, Alex increases the monthly payment. The new monthly payment gives Alex a balance of $500,000 in his annuity after a further 2 years. Okay, so and then it says, what is that new monthly payment? So this is definitely a change. You should know this note. This is a change scenario thing. So change in scenario. So what we like to do with these, we like to do the first bit and then move into the next bit. So I'm going to talk about his first 4 years. We need to know what this investment was, the final value at the end of that first 4 years. So we'll go through that. So 4 years would be 4 times the monthly. The interest rate, they said, was originally 3.8. The PV, as I said, we worked it out because his perpetuity would not have grown. It would have just remained the same. He's adding an extra payment of negative 500, and FV is what I want to know, and PPY is 12. Okay, so we want to know this so we can continue on with the next 2 years. So when we do that in our calculator, we get 444,872.94. So then we're going to move into the next 2 years. Because remember, when we have a change of scenario, we like to sort of start again. So he wants, at the end of the next 2 years, he'll have an FV of 500,000. So, and we want to know what the new monthly payment is. So if I wrote out all those the titles, FV and PPY, and it's still monthly, so we know that's 12. Now, if we've got the next 2 years, so it's 2 times 12. The interest rate, they haven't said it's any change, so we're going to keep it at 3.8. Now, the PV, is going to be, we're going to invest, like we're investing the current amount again. So we have to make that negative. So that has to be negative because it's like we're investing, we're starting again. And we want to know what the payment is when this account reaches 500,000. So if we do that, you'll see it says negative 805.65, but they're just asking what the new monthly payment is. So the answer would be new monthly payment. You're going to write it as a positive. It's not, we don't say negative, you just say you're going to make a payment of 805. We know it means you're giving it to the bank. That's what the negative's telling you, but they're asking just what that is. So you write it like that. Right. So Mariska plans to retire from work 10 years from now. Her retirement goal is to have a balance of 600,000. So what they told you there, they told you an FV at the 10-year mark. Yeah? So we want to, at 10 years, what we want it to be. And at the present value of the annuity investment is this. So this is pretty much telling us our PV, and we know when it's an investment, that's a negative. And she earns an interest rate of 3.24. So there's the I, and compounding monthly PPY equals 12. All right. To make the investment grow faster, she'll add $1,000 at the end of each month. So that's a negative payment, giving it to the bank. And 2 years from now, she expects the interest rate of the investment to fall to 3.2. So the compounding monthly. It is expected to remain this rate until she retires. So we've got the little change of scenario here. So change of scenario. And what we got, and it says after that it'll continue on with this. So if you've already gone 2 years, we've got 8 years left in this part. Okay, so we might write that because we know then that we're going to have 8 times 12. Okay, so that's what's going to happen, and she'll keep going until she retires. When the interest rate drops, she must increase her monthly payment to reach her retirement goal. So this was her retirement goal. So there's the FV, but we probably want that at the end. It's actually going to be at the end of our 8 years. That's the 8 years ending, because in total it was 2 years. So let's go through. When we have a change of scenario, we have to start it off and go through it. So we're going to go the first 2 years of the scenario. Sorry, yeah. So we go N, we've got 2 years at monthly. The interest rate was originally 3.24. So just might need to note we got a new interest rate in the second scenario. So 3.2, PV was negative. They told us what she had to begin with, and that was there. Okay, payments, she originally was adding an extra 1,000, so I'll do that. FE is what I want to know at the moment. We want to know what she's up to at the end of the 2 years, so we can keep going on the second part of the scenario. So when we do that, she's got it up to 307,794.50. So now I'm going to do the next 8 years. And in the next 8 years, we had a change in interest rate. It was 3.2. So 8 years is going to be 8 times 12. Now the PV is where we're going to pretend we're starting again. So it'll be this number but negative. The payment is what they want to know. So that's actually the question. What's the new monthly payment? So that's the question, because she wants to be able to retire on the 600,000, sorry. So that'll be a positive. She wants to get it to there. PPY is 12. And when you do that, I end up with 1854.05. So it just says which is it closest to. So E.